stationary points occur when f dash of x is equal to 0. For each of the following functions, find and classify any stationary points. Sketch the function showing all important features. So A, f of x is equal to x squared minus 2. So f dash of x is equal to 2x. So we want f dash of x to equal 0. Therefore, 2x equals 0. Therefore, x equals 0. So we have a turning point or a stationary point when x is 0. So if we draw our sine diagram for f dash of x, we know there is a stationary point at x is 0. So if we test a negative number, say -1, so 2 times -1, it is negative. Then we try something positive. So try 1. 2 times 1 is 2, which is positive. So we have negative, 0, positive. So we have a local minimum at x equals 0. We need to know what the value of that local minimum is. So we need to find f of 0, which is equal to 0 squared minus 2, which is minus 2. So the local minimum occurs when x is 0 and has a value of minus 2. We can now sketch the graph. So if we do a sketch here, we need to go down to minus 2, where the minimum is. So we know it's a quadratic. So there is a quick sketch showing that we have a local minimum at x equals 2 and the value is minus 2. So we've got B. F of x equals x cubed plus 1. We need f dash of x, which is 3x squared. To find the turning point, we want f dash of x equal to 0. Therefore, 3x squared is equal to 0. Therefore, x is equal to 0. So we have a turning point when x is equal to 0. So we do our sine diagram for f dash of x. So we need a negative number. So if we test for -1, -1 squared is 1, times 3 is 3, so it is positive. Now let's try for 1. So 1 squared is 1, times 3 is 3, so it is positive. So we have positive, negative, positive. So we have a point of inflection at x equals 0. We also need to know what the y value is, so we need to find f of 0, which is equal to 0 cubed plus 1, which is equal to 1. So we can now draw our graph. We know we have a stationary inflection point there, so it goes positive, inflection point, positive. So that is our graph of f of x equals x cubed plus 1. C. F of x equals x cubed minus 3x plus 2. So we want f dash of x, which is equal to 3x squared minus 3. So we want f dash of x equal to 0. Therefore, 3x squared minus 3 is 0. So 3x squared equals 3. So x squared equals 1. So x equals plus or minus 1. So we have turning points when x is 1 and minus 1. So if we do our sine diagram, so minus 1, 1. So we want to test to the left of minus 1, so say minus 2. Minus 2 squared is 4. 3 times 4 is 12. Minus 3, so it's positive. We can do 0. So when x is 0, the gradient is minus 3, so it is negative. And then we'll do to the right of 1, say 2. So 2 squared is 4, times 3 is 12, minus 3 is 9, so it is positive. So at x equals minus 1, it goes positive, 0, negative. So we have a local maximum. And at 1, it goes negative, 0, positive. So we have a local minimum. I need to know what values the maximum and the minimum have. So I need to do f of minus 1, which equals minus 1 cubed minus 3 lots of minus 1 plus 2, which is equal to minus 1 plus 3 plus 2, which is equal to 4. And we need to do f of 1, which is equal to 1 cubed minus 3 lots of 1 plus 2, which is equal to 1 minus 3 plus 2, which is equal to 0. You also need to find the y-intercept, so I want f of 0, which is 0 cubed minus 3 lots of 0 plus 2, which is 2. Now I can draw the graph, so let's draw in the axes. So I need minus 1 and 1. Need to go up to 2 and then up to 4. So I've got a maximum there. I go down there and then I go along and up there. So that is a good representation of my function. And D, when f of x is equal to x to the power of 4 minus 2x cubed. So we need f dash of x, which is equal to 4x cubed minus 6x squared. So I want f dash of x to equal 0. Therefore, 4x cubed minus 6x squared equals 0. Factorize with 2x squared. That's 2x minus 3 equals 0. Therefore, 2x squared equals 0, or 2x minus 3 equals 0. So x equals 0, or x equals 3/2. Now do a sine diagram. So let's have a look. We've got x is 0, x is 3 over 2. So this is for f dash of x. So we need to test something below 0, so minus 1. So minus 1 cubed is minus 1 times 4 is minus 4 minus 6 times minus 1, so that's going to be negative. So we want something above 0 but less than 1.5, so we'll do 1. So that would be 4 minus 6, which is minus 2, which is negative. And then we need something above 1.5, so we'll do 2. So 4 times 2 cubed, so 2 cubed is 8, times 4 is 32, minus 6 times 4, so that is 8, so that is positive. So we have negative, 0, negative, so that's point of inflection. Then we have negative, 0, positive, which is a local minimum. Now we need to find the value of the local minimum. So we need to find f of 3 over 2. So that is equal to 3 over 2 to the power of 4 minus 2 lots of 3 over 2 cubed, which is equal to 1.69. Now I can draw the graph, so let's draw the axes. So it comes down here, goes along there, down there, and up there. This point is 1.5, and that is what this function looks like. Let's go back to one we've done before. So f of x is equal to x cubed minus 3x squared minus 9x plus 5. So we need f dash of x, which is equal to 3x squared minus 6x minus 9. We need f dash of x to equal 0. Therefore, we want 3x squared minus 6x minus 9 equal to 0. Therefore, we got x squared minus 2x minus 3 equals 0. So we've got x minus 3, x plus 1 equals 0. So x equals 3, or x equals minus 1. Now, instead of using a sine diagram to find the nature of the turning points, we can use the second derivative. So if we find f double dash of x, so we differentiate 3x squared minus 6x minus 9, which will give us 6x minus 6. And we want to find the value of the second derivative at our turning points. So f double dash 3 is equal to 6 times 3 minus 6, which is equal to 12. At minus 1, the second derivative is equal to 6 times minus 1 minus 6, which is equal to minus 12. Therefore, when the second derivative is less than 0, we have a maximum. When f double dash is greater than 0, we have a minimum. Therefore, at f3, we have a minimum at f minus 1, we have a maximum. We can now sketch the graph. So we've got something that looks like this. So that is at minus 1, that is at 3. And when x is 0, f of x is equal to 5.